Hi guys, I hope you're doing well. Today we are going to work on finding what's called the compound probability of certain situations. So compound probability happens when you have more than one event happening, and we're going to talk about independent and dependent events first, and then how to get the actual probability value given the independent and dependent nature of those events. So please watch this video all the way through. Pause it if you need to, if you're confused, or rewatch it if you want to at the end. Please feel free to send me an email. This is a little bit of a trickier concept and idea. When you do your work today, I'll allow you to do the assignment multiple times. But if you're still getting it wrong and you're not sure why, please reach out and ask for some help. So our goal today is to be able to use ratios to calculate the probability of two conditions occurring in one event. So basically what we're talking about today is how to find the probability of two things happening. So for example, flipping a head and rolling a 2, if you would flip a coin and roll a dice. Okay, so things like that is what we're working on. So when we think about probability, okay, what we've talked about so far is simple probability. Okay, we found the probability of a single event occurring. What's the chance that out of a box of markers you pick a red one? Okay, something like that. Whereas compound probability is the probability of more than one event happening together. And to find it, what we're going to do, if we want to know the probability of something and something else happening together, we're going to treat this kind of like the slots idea that we did the other day with counting principle. We're going to find the probability of the first event, and then we're going to find the probability of the second event, and we're going to multiply them together. Okay. When you're using Desmos today, you're going to want to make sure that you have fractions. Okay, so this little button over here, I don't know, some of you might not have realized this. When you get a decimal answer, there's a fractional equivalent right here, so you can click on that to get the fraction. So if you need that today, you can use that. So independent and dependent events. So when we think about what it means to be independent, independent means it doesn't impact the next event. Okay, so an example would be you draw a card from a deck, but then you put it back. So that doesn't change the number of cards in the deck. It doesn't change what's available for someone else to get. Okay, so it's an independent event. Okay, a dependent event. Okay, the second event is going to be different depending on what happened in the first event. So if you draw a card, okay, and then you don't put it back in the deck, that means now there's less cards in that deck. So if you're looking for a specific card, if that first card was that card, you don't have that option anymore. There's a 0 chance you'll get it on that second one. Sorry, Skyward kicked me out again. So dependent events are really important to understand, and they're often based off of how something is changed. Okay, so I want you to take a look at this situation here. Okay. It says a drawer, so sorry that it's hard to read. A drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and then replaced. Another paper clip is taken from the drawer. What's the probability that the first paper clip is red and the second paper clip is blue? When I look at that situation, okay, the first paper clip that we're talking about, to know that it's red, okay, we would look for 3, okay? So we want to know that the first one is red. It's going to be 3 out of 3 plus 4 is 7. Okay, plus 5 is 12. 3 out of 12 times we would say that the first one would be red. Okay, and then it's put back in the drawer. So the fact that the second one is going to be blue, there's still 12 possibilities for that second paper clip. Okay, and it's going to have 5 possible blue ones. So to find the probability, we would multiply these. Because the denominators are staying the same here, okay, that's indicating that this is an independent event because nothing from the first event impacted the second event. If we read this example, it says a drawer contains 3 red paper clips, 4 green ones, and 5 blue ones. 1 paper clip is taken from the drawer and is not replaced. This is really your key here. If something is not put back, that's going to be a dependent event. Okay, that's going to indicate that events are dependent on each other because that means that first event, okay, is still looking at red here. So red would have a 3 out of 12 chance still of happening, but that blue one has a 5 out of 11 chance of happening now, because this number has changed because that first paperclip wasn't put back. Okay, so independent events act just like normal probability. You're going to multiply them together. Dependent events are a little bit trickier because you're going to be changing something. Something is changed because of the first event. So let's take a look at these three examples. Okay, and we want to label them as independent or dependent. Okay, so remember, independent, all right, nothing impacts each other. Dependent, something in the first event impacts the second event. So Anne draws a colored toothpick from a jar. Without replacing it, she draws a second toothpick. Well, if she doesn't replace it, okay, that means that it's going to be a dependent event because the second toothpick's chances are different because the first toothpick wasn't put back. John rolls a 6 on a number cube and then flips a coin that comes up heads. Well, I know a number cube is just a die, okay? And a coin are totally separate, okay? Rolling something on a number cube and flipping something on a coin have nothing to do with each other. Those are independent events, okay? One doesn't impact the other. Susie draws a card from a deck and then, oh, she replaces it. Because she replaces it, those are independent events, okay? They don't impact each other. So now let's think about what we know about probability. And now what we're going to do is we're going to find compound probability, okay? So compound probability is when more than one thing is happening at a time, okay? So we want to know the probability that these spinners here, you get a B and you get a 3, okay? Now, if we take a step back to what we did on Wednesday, we could draw a tree diagram for this, okay? We could draw something like, okay, here's our brain. We can get A, B, C, or D, okay? And then we could write out our combinations from this. But what we're trying to do is we're trying to say, okay, we could do that, but could we also just go straight to the probability, okay? So here's how this works. I know I'm looking for the probability that it's a B and the probability that it's a 3. So I'm going to make 2 slots here. And because I see this word and here, I know I'm going to multiply these 2 probabilities together, okay? So the probability that it's a B is 1 out of 4. So I'm going to put my fraction there, 1 over 4, okay? And the probability that it's a 3, when I look at this, there's 1, 3 out of 6 possibilities, okay? So what that means then is if I multiply this through, there's 1 out of 24. There's a 1 in 24 chance that if I spin the spinner, both these spinners, I would get a B and a 3, okay? If we would make this on our tree diagram, okay, from the A, we would have 3 1s coming off of it. We would have 2 2s, and we'd have a 3. Okay, we'd have 1, 2, 3 1s, 2 2s, and a 3 coming off of it. If you notice, if we're looking for a B and a 3, that's the only time that's going to happen, is right there, that one option there. Okay, so that's why this is a 1 in 24 chance. If we would continue doing this, these are 6 options on each letter, which gives us 24 total possibilities. Okay, only one of them has a B and a 3. That's why this answer makes sense. Okay, now these are independent events because this spinner doesn't impact this spinner. So let's look at this one. The probability that it's not D and a 1. So not D. Okay, what's the chance of that? Well, not D, so it can't be D, so it could be A, B, or C. So that means it's a 3 out of 4 chance there. Okay, and a 1, right, on our spinner is 1, 2, 3 out of 6, which is a 1/2 chance. So when I multiply this, I've got a 3 out of 8 chance of it not being a D, okay, and being a 1. When I think about that, that basically says in here, okay, I can have anything that's not a D and a 1 together. Okay, so there's those 3 options here, there's these 3 options here, and there's going to be these 3 options here for the 1s. Okay, that's going to be 9 out of 24. When we reduce that, we get 3 8s. Okay, so the tree diagram can be helpful, but it also gets a little confusing and a little bit messy. Okay, using fundamental counting principle, we knew there were 4 options here and 6 options here, so that's where we get the 24. Okay. if some people's brains work really well with this, other people's brains have a really hard time. So if you're struggling a little bit, it's okay. Just make sure you reach out and ask for help. Okay. So let's read this. A box contains 3 red marbles and 6 blue marbles, 1 white marble. The marbles are selected at random, one at a time, but they're not replaced. Okay, that's going to be really important here that I notice that. Find each compound probability. Okay, so if I want to know the probability that it's blue, that I get a blue and a red. Okay, so I'm going to just deal with this first one here. Okay, so if I want a blue and I want a red, okay, what I know here, right, if I'm supposed to do blue first, there's 6 blue out of 3, and 6 is 9, and 1 is 10. So 6/10 of the time, okay, we'd have a chance of getting a blue. Now the red, okay, if it's not replaced, if I've taken a marble out, okay, that means now there's only 9 options. Okay, so a box contains 3 red marbles and 6 blue marbles and 1 white marble. The marbles are selected at random, one at a time, and they are not replaced. Find the compound probability. That means right now I've got 9 marbles, and I think I've still got 3 red ones. Okay, because there's still 3 red there. So if I pull a blue, it doesn't impact the number of red, but it does impact the total number that I have. So now I'm just going to multiply my fractions. I know when I multiply fractions, I can cross cancel. It's going to be a 3, that's going to be a 2. I'm going to end up with 6/30. Okay, divide them both by 6. And I end up with 1/5. Okay. So 1/5 of the time here, okay, we would say that we would get a blue and a red marble. Okay. So we cross canceled there. Just checking my math. These 3's could have canceled, and that's where. Okay. Now, if we do the probability that we get a white, a red, and a white, let's look at that here. Okay. So if we're looking for white, red, and white, the probability that I get a white is 1 out of 10. Okay, there's only 1 white one there. The probability to get a red is 3 out of 9 because I've taken that one out. Now the probability to get another white, okay, if I've already gotten 1 white here, there's a 0 out of 8 chance, okay, of that happening. So the probability that I get a white, a red, and a white, when I multiply this, I know multiplying anything by 0 is going to give me an answer of 0, okay? The reason I know this has a chance of 0, a 0% chance of happening, is because there's only 1 white marble. This wants 2. Okay? So you have to be careful what you're watching for here. So this is an example of dependent, okay, events versus the first one was an example of independent events. Now, if you want to go ahead and pause the video and try this on your own and then check back here, you can hit play and check on your own. If you want to just watch the example, that's fine too. So it says you have a bag of 17 colored chips. 4 are blue, 6 are green, 2 are red, and the others are yellow. What's the probability of drawing a blue chip, putting it back or replacing it, and then drawing a yellow chip? Okay, so I'm going to start off with what I know. So if I'm looking for blue first, and then I'm looking for yellow, I know there's 17 total, and it says 4 of them are blue. So the chance of blue is 4 out of 17. Now, if I replace that, that means the total number stays at 17. Okay, and the probability of yellow, if 4 are blue and 6 are green, that's 10, and 2 are red, that's 12. That means 5 of these, okay, are yellow. So we're going to go ahead and multiply across. This is going to be 20 over, oh goodness, 17 times 17, 49, 111, 7, 1, 9, 8, 289. Sorry guys, I'm using my phone as my Zoom, so I can't multiply. So I've got 20 over 289. Now, this was an example of independent events because they didn't impact each other. Okay, this one here, go ahead again if you want to pause this, all right, try it on your own, and then check in a minute. You can do that. If you want to just watch the video, that's fine too. It says if you have 3 quarters, 5 dimes, and 2 nickels in your pocket, what's the probability you will pick a nickel and then a dime without putting the nickel back in your pocket? So if I want a nickel and then a dime, I'm going to make my 2 slots there. So I know that's what I'm looking for. So my chance of a nickel is 2 out of 10. I add up my quarters, my dimes, and my nickels. Okay. And then my chance of a dime is 5. But if I've taken one out, that means my new total is 9. I can cross cancel here. That's going to be a 2. That's going to be a 1. So I've got a 2 out of 18 chance, divide them both by 2. I've got a 1 in 9 chance, okay, of getting a quarter. Oh, I'm sorry. You will pick a nickel. Yeah, this should say nickel here. Okay. Nope. A nickel and then a dime. Okay. My bad. So your work today is on Canvas. There's a link to the assignment in your description here. It says April 17th, compound probability day 1. Please get that done. There's a series of questions on there, just like what we have done in the video. Okay. If you're interested, there's Bill Nye made a probability video when he was doing his show. You can watch that online. I've posted the link there. Okay. Just for fun. So hope you're all doing well. Take care, and we'll check in again next week. If you are stuck on any of this, please make sure you're reaching out. You're coming to the help session at 3 on Friday. Next week, it's only going to run on Monday, Wednesday, and Friday. But if you need some help today, please make sure you're watching or you're checking in. Take care.